This lesson was about scientific notation, and scientific notation is written in the form of a number times 10 to a power, r times 10 to the nth power. And r has to be equal to but greater than 1, and it has to be less than 10. It's not going to be equal to 10, but it's going to be between 1 and 10, not equal to 10. So for example, we have 3.52 times 10 to the 5th. And each place value we've been learning is a power of 10. So what this means is we take 3.52 and we're going to go 5 powers of 10. So that means 5 place values. So we got 1, 2, 3, 4, 5. And we move the decimal. And then all these blank places we need to put a place holding 0. So we end up with 352,000. And we can go the opposite way, well, from a number to scientific notation. By counting the place, putting the decimal in and counting the place values. So I know that the R value has to be between 1 and 10, so I'm going to put the decimal after the 5, make it 5.25. So now I have a number that's between 1 and 10. And since the decimal was put there, we've got to count how many places it was over. 1, 2, 3, 4, 5, 6, 7, 8 places. So I can write this as 5.25 times 10 to the 8th power. And this is useful to denote really big or really small numbers. So let's practice a really small number. To denote the very small number, I take the numbers that are not 0, 3, 2, 3, 4, and I make it into a number that's between 1 and 10. And then, just like before, I put the decimal in. But now, because we're moving the decimal to the left, we're shifting the place values the opposite way. So I've moved it 4. And since I'm moving it the opposite way, we're going to show that with a negative exponent. So it's 10 to the negative 4th. So negative will be a really small number, and positive is going to be a really big number. We can also do, using our laws of exponents that we've been learning, we can also do computations with these. So for example, if I have 6 times 10 to the 8th, and I divide it by 3 times 10 squared, I can actually split these fractions up and compute it that way. 6 divided by 3 is 2, and 10 to the 8th divided by 10 squared is 10 to the 6th power, because 8 minus 2 is 6, using our laws of exponents. And you can do it no matter what the numbers are. If the numbers are decimals, then you can make this a decimal. You split it up the exact same way. You can also multiply in the same way. And this time we'll use commutative property. And associative property to switch the order. 3.5 times 2 will give me 7. And 10 squared times 10 to the 3rd is 10 to the 5th. So we can do all of these computations pretty easily with our laws of exponents. However, the tricky part comes when we have something like this. Well, now we have multiplication, but in the middle we have addition. So we can no longer use the commutative property to switch the order because we have mixed signs. They either all have to be multiplication or they all have to be addition in order to do anything. So what we're going to do is work with this. If the signs are the same, so for example, let's come off the side here. If I have this, and the signs are the same on the exponent of the 10, I can actually just stack these on top of each other and treat this 10 squared like a like term. Okay, there's still 10 squared. You're moving the decimal place two places in both of them. So you're still going to move the decimal places 2 in both of them. And then you just add numbers like normal. And you get 7.52 times 10 squared. So it's easy when the exponents are the same. However, when the exponents are not the same like we need to make the exponents the same so that we can add them easily. So I'm going to rewrite 3.52 and I'm going to decompose 10 to the 8th by using our laws of exponents. So I'm going to make it 10 to the 6th times 10 squared. So 10 to the 6th times 10 squared should be 10 to the 8th power. So now we have an equivalent statement. Okay. And what we're going to end up with is we're going to stack the like terms. So now I've moved this term over here because we were just adding. I think I forgot to write the addition sign. We were adding this on, so I'm just going to move it and add it vertically instead of horizontally. And now I'm going to get 7.62 times 10 to the 6th times 10 squared. And then I'm going to get 7.62 times 10 to the